So multiplying numbers. So when A and B are real numbers, square root of A times square root of B equals square root of A times B. This is not true when A and B happen to be non-real numbers. So we're working with complex numbers here. So remember this. If I have an I squared, that is going to equal a -1. So if I had 3 plus 2i plus 5i, and I distributed this across, well, we're going to have 3 times 5i, and then you have 2i times 5i. So here I just have the 1i. You're just going to multiply your real parts together. So 3 times 5 is 15. And then I didn't have anything to multiply to, so it's left alone. Multiply your real parts. 2 times 5 is 10. Well, I times I is I squared. We said I squared is a -1. So what's going to happen is that this is going to end up being 15i plus 10, and then this turns into a -1. So it's not 10 times I squared, it is 10 times -1. So what we're going to be left with is that this is going to turn into a 15i minus 10. But like I said, we always try to write the real part first, but if I rewrite it, that turns into -10 plus 15i. So for example, let's say we have these two numbers. Well, we know that this is just, because we already found it once, 4i would be our square root of -16. The square root of -25 would be 5i. So always convert it like this first. Make sure you put those i's out before you keep trying to go, because otherwise you might think that's negative disappears. So make sure that you pull out that I first. We multiply that together. That is going to be 20i squared. Or 20 times -1, it will be -20. Here we're going to FOIL. So I times, or 1 times 1 is 1. And then we get 1 times 3i. 2i times 1 is 2i. 2i times 3i is going to be 6i squared. So we get 1 here, like terms, 5i. And then this down here is turns into 6 times -1 because of that I squared. Which means that we just have -6 down here. So we have -5 plus 5i. Then C is going to be foiling again. It's just that we have 3 minus 7i squared. So my complex number squared. So you just expand it, and then we're going to FOIL. 3 times 3 is 9. 3 times 27 is 21, so that's going to be 21i. Then -7i times 3 is another -21i. Ugh. And then -7i times -7i is plus 49i squared. So you get 9 minus 42i. And then remember that this I squared is just negative, so it's not plus 49i squared, it is minus 49. So -40 minus 42i. So take a minute and work on A, B, C, D, and E here. Oops. And then come back to the video and we will go through it. Okay. So once again, like FOIL, -1 times 6 is -6. -1 times negative square root of 3i is plus, and so the I should have been out first, but I square root of 3. So, but it's going to be positive. Then we have minus this minus 12 times 6. So 6 times square root of 12. Then the square root of 12 times this. So it's going to be a plus square root of 12 times square root of 3i. So no place did my i's kind of double here. So we can't really do anything about this 6 square root of 12, except one little thing. So I'm going to put it over here. So remember, 12 is just 4 times 3. And the same thing over here. I'm going to just put my complex parts together over here. The only thing I can do a little bit more here is break down that 12, which I said is 4 times 3. So we're going to have negative 6 times minus negative 6. So that's a square root of 4. So this would be 2 square root of 3 if we simplified it. Same thing here. We have this, what used to be square root of 2, which we turned into 4 times 3. Square root of 4 times 3 is just really 2 square root of 3. So we're going to have a nice monstrosity here. I can multiply the 2 and the 6. And I'm left with this I, square root of 3. And then these will multiply together. So that'd give me 3 times 2. So that'd be 6i. All right. And that is about as simplified as I get it. If you want to make it look more like a complex number, you might just pull out that I like that. But yeah, that one was just a little bit of a monster. Well, this one should be a little cleaner. So these we had mentioned before. So I have 2 minus 3i, 2 plus 3i. These are what we call conjugates. So we had before where it was, which is a plus b when we were doing factoring. But if we have two numbers like this, where it's the addition of the numbers and the subtraction of the numbers, that are your conjugates. So conjugates do something a little interesting when we're dealing with complex numbers. So you're going to have 2 times 2, which is going to be 4. 2 times 3i, which will be 6i. Then we have a negative 3i times 2, so negative 6i. Then we have negative 3i times positive 3i, so that's going to be negative 9i squared. So you notice that these cancel out. And then because we got this square root of I here, that is just going to be negative 1. So this is really just 4 plus 9, or 13. So when you multiply conjugates, one of the cool things that will happen is that if they're conjugate complex roots, complex numbers, they will give you a real number. All right, and this was another one we just need to expand. So if we expand it, then multiply, we got negative 3 times negative 3, so positive 9. Negative 3 times 2i, so negative 6i. 2i times 3, negative 3, so another negative 6i. I'm starting to stumble here. 2i times 2i is going to be 4i squared. So we got 9 minus 12i. Like I said, this I squared is going to change that from a positive 4 to a negative 4. So we really have 5 minus 12i. Okay. Let's get a different color here so we can see this one. So this one, remember, these are going to be complex numbers. So this is actually I square root of 3. And this is I square root of 2. So when you multiply them, you get a square root of 3 times the square root of 2. And then you have an I squared. So just like if I have two things multiplied under a radical or a square root, I could break up the square root. I can also combine the square root. So as long as these are multiplied, I can bring these inside and I have a square root of 2 or 3 times 2. And then we have that I squared. And what we'll end up with is your I squared is just going to be a negative 1. So we end up with negative square root of 6. So you have to remember to take that I out first, because if you don't, you're going to end up with the wrong answer. And then this one, only one of these is a complex number. So we have square root of 3 times I square root of 2. So this one, you'd keep the I because I don't have anything to multiply it to. So this is just I square root of 6. So we had just demonstrated this. If I have two numbers that are positive numbers, then what I can do is, like I said, if I have square root and they're multiplied together, I can just bring them together and multiply them. If one of them happens to be complex and one is real, what we saw is that that negative got pulled inside when we multiplied the square roots. We'd have that negative a times b now. I think that one's a typo. That should be the negatives in here. If we have two negatives underneath and we multiply them together, then that negative got pulled out front. So an extension on this is raising your i's to a power. So recall that negative 1 raised to the power, an even power is just 1. And that negative 1 raised to an odd power is negative 1. So simplifying powers of I can be done by using the fact that I squared is negative 1 and expressing the given power I in terms of I squared. So we know I is just square root of negative 1. We know that I squared is negative 1. So I cubed, it's just I squared times I. So it's going to be the negative 1 and then the I. So we get a negative I. I to the fourth, well, that's just I squared squared. So that is negative 1 squared. So that'd be a positive 1. If it's to the fifth, that's I to the fourth times I. And we are just established that I to the fourth is just going to give me 1. So we're just going to get I back. Oops, so I accidentally left my solutions on this wrong slide. So we're going to simplify the following. We got I to the 37th. Well, one of the things we can change this is I to the 36 times I. All right. So going back to something that we kind of already did. There we go. This is just I to the fourth times 9 times I. So what we saw earlier is that my I to the fourth is really just I squared to the 9. So we know, once again, that I squared is just negative 1. And then I'm going to square that. Oops. And that's all raised to the ninth. So I squared is just 1 raised to the ninth. We're just left with I. Okay. So then for the next one, I to the 59th. Well, that is really I squared, right, to the 29th. So we're using those powers of exponents. So we know I squared is -1. So -1 to the power of 29. So we are going to have a odd number of negatives. An odd number, -1. So anytime we have an odd number, it's going to stay negative. So this is going to stay -1. Okay, second. I'm just going to get this other one up and going for us. Okay. So once again, we're trying to figure out how we're going to break this apart. So sometimes it's just a little easier just to break up an I. All right, so we have to do 2 again. So this one, I to the 74th is just I squared to the power of 37. And then we have that I out here. Once again, we know that's a -1 to the 37th. We have an odd number of ones. So that is going to stay a -1, and we keep that I. So this is just -I. All right, and then the last one is 80. So 80 is just 2 to the power of 40. So that is -1 to the power of 40. So now we have an even number of negatives, -1s. That is going to turn into a +1. So we already mentioned conjugates. So we said in general, conjugates were just two numbers that are subtracted to each other and then the two numbers added to each other. So when we talk about complex conjugates, it's the same idea, except it's your real number plus the imaginary, or the real part plus the imaginary part, and then you write as the real part minus the imaginary part. So it's the same as like A minus B, A plus B. It's just you have that I there. But those are your complex conjugates. And we already saw what happens when you have complex conjugates. So like these two here, we have -3 plus 7i, and then we have -3 minus 7i. So when we multiply those, what happens is that it's going to get rid of the complex number and turn it into a real number. So like I said here, if we multiplied this out, we expanded it or oiled, these i's disappear, but this one's squared at the end. So that is not just I squared, that is a -1. So we have 40, sorry, that turns into a +49. And then we're going to end up with 58. So one of the things we like about complex conjugates is that it has this property. But this is also why when you have you could factor a polynomial that doesn't have complex numbers and it'll have complex roots, because we can multiply these two complex roots. And what's going to happen is the complex part, it will disappear and you're just left with real numbers. So we'll see that here in a bit. But if you can for a second, just pause and just see if you can figure out what the complex conjugate of each of these would be, and then multiply by that complex conjugate. Well, first, let's start with the conjugates. So the first one was easy. We had 5 plus 7i, so its conjugate would be 5 minus 7i. B is not so straightforward. We have 8i. So remember that if we wrote this like a complex number, we have your real part and then your imaginary part. And the imaginary part is the part we add and subtract. So if we wrote it out like 0 plus 8i, its conjugate would be 0 minus 8i, which once again, if we simplified it, is a negative 8i. So let's multiply by those. So first is a, so we have 5 7i times 5 minus 7i will give me 25 minus 35i plus 35i minus 49i squared. These cancel. This is just 25, and this becomes a positive 49. So we see 9, 10, 11, 12, 13, 14, 4, 5, 6, 7. Okay, 74. Same thing here. We have 8i, and its conjugate is negative 8i. If we multiply those, we're going to end up with a negative 64i squared, which we know this is just going to be positive 64 then.